So let's look at another one.
I'm ready, so let's go.
Okay, here's a second example. 4y double prime minus 4y prime minus 3y equals cosine of 2x. Now, keep in mind, the first thing we want to do is solve the homogeneous equation as if this wasn't cosine of 2x but was 0. So we solve the homogeneous equation. That has a characteristic equation 4m squared minus 4m minus 3 equals 0, and that factors into 2m plus 1 times 2m minus 3 equals 0, so m equals negative a half and m equals positive 3/2. So our complementary solution of y sub c is c1 times e to the negative a half x plus c2 times e to the 3/2 x. So now our guess, we're looking at this right hand side and it's some linear combination of cosine and sine, so that tells us we have to have a yp that is some linear combination of cosine and sine. Then we have to determine the coefficients a and b. Remember, determining the coefficients. This is what's called undetermined coefficients. There's a reason why it's called that.
How dare you?
Well, I mean, I didn't mean to insult you, but I mean, there's a reason why it's called undetermined coefficients, and that's just why it's like that.
I don't understand.
Well, see, we set up a yp that we don't know its coefficients, and then we plug that yp into the equation and find those coefficients.
I'm so ready.
So let's do it, okay? If this is our yp, then the first derivative of this function would be negative 2a sine of 2x, see? Plus 2b cosine of 2x, right? And then we also want to find the second derivative. So we're going to have to plug it back into this equation right here. So we need the second derivative. So y double prime, well, take the derivative of this. We're going to get negative 4a cosine of 2x. Take the derivative of this, we're going to get negative 4b sine of 2x. So there we've got that. Now, going back into this equation, the original equation, what I did, I copied and pasted the thing in here. And let's see what we wind up with. Negative 16, that's 4 times the, remember that was 4 times the negative 4a cosine, so that would get now negative 16a cosine of 2x minus 16b sine of 2x. See that I'll just plug this in for this, right? So that is done. Now we also have this first derivative right here. This gets plugged in for this yp, right? And so that's what I did here. I made it 8. I don't know why, but I put the remember that was negative 4, so negative 4 times negative 2 makes positive 8a sine of 2x, and then negative 8b cosine of 2x. I hope you see why it's that. And then finally, 3 times the original function y, well, that's 3 times a times cosine 2x minus 3 times b sine of 2x. And all that's got to be equal to cosine of 2x. Now, I don't know if you see it right now, but that's going to give us a way to solve for the a and the b.
That stuff coming up.
Yes, and here it is. Cosine of 2x on the left-hand side has negative 16a minus 8b plus 3a as its coefficients. And that has to be equal to 1 times the cosine of a on the left-hand side. So that means negative 19a minus 8b has to be positive 1. Hopefully you see that, right? Because I need to have 1 times cosine x on this side, I need to have 1 times cosine x on this side. Now, sine of 2x has these coefficients, negative 16b, positive 8a, and minus 3b. So that means we got 8a minus 19b, and that's equal, look, there's no sign on the right hand side of the equation, it's just cosine, so that equals 0. So now we have a system of equations, negative 19a minus 8b equals 1, 8a minus 19b equals 0. Honestly, I know I cheated a little bit. You could use Kramer's rule. You could use any method. You could use substitution, but it'd be kind of ugly. But you will get a equal to negative 425ths, sorry, and b equal to negative 8 425ths. Where do we get numbers like that? Ooh-wee!
It's me!
No, it's no one's fault in particular. We just got numbers like that. That's all. So we got numbers like that. It was a nice surprise that we got these ugly numbers for a and b, but we've got our yp. So the solution, y equals yc, complementary solution, plus the particular solution. Here's the complementary solution. I don't know why I have parentheses around that, but I do for some reason. Oh, what happened? There we go. Better now, although I still don't like the way that notated. There's something I really don't like about this software, and that's when I'm not using it full screen. It does some horrible things sometimes. And I'm not using it full screen, so I get a little bit better picture of this on the web. There we go. C1 times e to the negative a half x plus C2 times e to the 3 halves x. We already had that part. And then we just discovered our coefficients a and b. And as horrible as they are. If we're a little uncertain, there's a chart on page 172, but you could look it up on the internet to say, find possible solutions for undetermined coefficients problems. And you know, these are the ones that are kind of ours and are simple, but undetermined coefficients works for even worse problems than we're seeing, for what it's worth.
I think that this is your way of telling me something.
Yes, and I'm telling you, this works.